Hello everyone. In this video we are going to look at sheet metal design in Fusion 360. There are some toolbars here. The first one is create, which has new component, and then flange and bend and convert to sheet metal. Although we have some other ones too, like extrude, hole, thread, pattern, mirror, and so on. Then other modify other than fillet and chamfer, we have unfold and sheet metal rules and rip. And another thing we have here is this guy called create flat pattern. So these are the major sheet metals, and assembly is separate really here, although you can assemble sheet metals, but that's not the goal for this video. We just want to look at creating sheet metals, not assembling them together, because the basis of assembly for sheet metals is the same as rigid bodies. So here I'm going to show you how to make stuff like these, right? And create flanges, bend the sheet metal, create lofts, create rips, change the type of the sheet metal and the rules for the sheet metal, pattern holes, stuff like that, fold and unfold, and convert a solid body, in this case like a step file, into a sheet metal and so on. So let's see how this is all done. Okay, so the first thing I want to show you is this option says convert to sheet metal, and for that I'm going to bring in a step file. I'm going to open up a step file, and then I'm going to convert that step file into basically this one. I'm going to convert that step file into a sheet metal. So if you look right now, you see it's a solid body. Okay, you see the symbol of solid bodies. Remember, solid bodies are cylinders, surfaces are orange, basically 2D shapes, and sheet metal has its own symbol. So let's see how we do that. And so here I go under sheet metal, and then I use this option create, and then I pick this surface, and automatically it finds the thickness of the part and applies that as the thickness of sheet metal. And the rule for sheet metal here is steel. Okay, but if you want, we can change it, and I'll show you how to do that. Okay, so right now it applies a steel 2.5 mils, which comes from the thickness of the part. And now look here what happens. Remember, it was a cylinder, now it is this sheet metal symbol. So now the part is converted to sheet metal, right? And you might say, now that it's a sheet metal, can I, for instance, created a flat pattern of this, right? So if I click on this face and say this is my stationary face and lay it flat, does it do it? And the answer is yes. Look, here is the flat version of what that sheet metal that you need to make that part. And if you need to cut this with a let's say a water jet machine or any laser or anything that you want to cut it, you can export this right now with export, and you can export it to DXF file, which is a common 2D drawing which is used by laser cutter machines or water jet machines. So here you can just go ahead and okay that, and let's call it, for instance, water jet part, right? And save it, and you can save it to the local drive or anything, and there we go. So it's done. And so this was the solid part that I converted to sheet metal, flattened it, and exported the DXF. This is the first thing that I wanted to show you. The next thing is to create a sheet metal from scratch, not convert a solid body into sheet metal. So for that, here we can go under create and start a new component, right? So here we click on start new component. It's a sheet metal, and then here is the sheet metal rule. These are different material that we have and the units they have. So it could be steel, stainless steel, or aluminum, right? So let's say I want one from aluminum, okay? And I okay that. So now whatever sheet metal you will make is going to be made from aluminum. Well, what would you do? So let's say here I pick on the sketch and I want it to be a rectangular sheet metal. I go on this top plane and I draw a simple rectangle, right? So let's say from here to here, okay, and get out. And now I can use the flange command and convert it into a sheet metal like that. Okay, so as soon as I okay that, there we go. That's a sheet metal, and you can see that by going under bodies. You see the body is a sheet metal. Now, how much is the thickness of this sheet metal, right? Because the rule for it is aluminum. And what is the rule for it? If you want here, you can click here and you can switch that to steel or something. But the first question is, how much is the thickness of that? If you bend it, right, if you make a flange on it or something, how much is the radius of the flange? For instance, I can click on the flange here and I can pick one of these edges and I can create a vertical flange like this for let's say height of 10, angle of 90 degrees, or let's say angle of 75 degrees or anything like that. Let's make it 120. Okay, and then you can put the height on the inner space, outer space, or tangent. You can fill up the direction of that if you want. Okay, so what is it that we have? Like, what is this radius right now that you have? What is this radius of this bend? Okay, that's coming from the rule that was aluminum. But how much is it? And can you change it? Well, can you change it? Yes. If you click here on override rules, you see that these are the rules from aluminum. For instance, if you go to bend override and check that, you see that the bend radius for this sheet metal is 2 mil. Do you want to change that? Here you can overwrite it. Or if there are more than 2 walls at the corner, so there are 3 walls, you need a bend relief, and the bend relief, the shape of it is straight. You can make it like a tear around, and I'll show you what I mean by that if you haven't seen my other videos about SolidWorks or CATIA sheet metal. You might not know exactly what a bend relief is. But here, these are the dimensions for aluminum rule. And if you want, you can change them, right? So you see, these are the numbers, right? And if you want, you can overwrite them. So here, let's say I don't want to overwrite them. But again, let's go back to the question of how much is the thickness of this material and what is the aluminum rule that we have over here. So here we go to modify and we look at here sheet metal rules. And if you expand this, you see this is aluminum, and if you expand that, you see the thickness of the sheet metal is 2, which is also the same as the radius of the bend. You see here, you can see bend radius is 2 mil. And then the relief is straight, and these are all the dimensions, and these are everything about the corners and the relief of the corners. But if you don't like that, there are other rules that you can pick. You can go under library, and there is steel, you see, stainless steel and aluminum in mils and similar things in inches. Okay, and guess what? You can even edit them if you want. So for instance, if you want aluminum, but you don't want aluminum to be 2 mil thick, you want aluminum to be, let's say, 1 mil thick, right? And then also you want, let's say, the bend condition. You see, the bend radius is the same as thickness. So if I change that 1, the bend radius should also be 1. Look, if I change that and I okay that, you see, the material is now 1 mil thick and the bend radius is also 1 mil because I edited the aluminum rule, right? So you can go ahead and change it, or you can make your own. As you just saw, I can make my own rule, correct? You see that here. I can click on this guy and I can create a new rule, and I can call it something else. Let's say if I have a different sheet metal, different thickness and everything, I can change that. I can change the K factor, which shows you the location of the neutral axis and everything. Okay, so you can create different rules for sheet metal here. Okay, so this was creating a simple sheet metal by inserting a new component, picking the rule, and then creating a sketch and applying flange to make a flat. And if you want, you can make more walls by applying this flange. For instance, if I go back to this flange, and let me make it 90 degrees, let's go back to 90. And remember the height was 15. So look, if I want, I can make the vertical walls on all of the edges instead of just one by simply here, I pick just that one edge, but you see here, it says full edge. If I pick full edge, well, it took the whole edge here. But if I say I want with offsets, Now I can have, look, I can have only a portion of this, basically a wall to be um, showing a flange, right? So here -10 and -10, you see, so this is a partial flange, right? And as I said, you can have it on all walls. I'll show you that, but you want to see something here. Look, when you cut it, you see there is no connection here. There is a relief here. Okay, so there is a gap between these two parts. That is a relief. But let me show you with vertical edges here. So let me go back and make it full edge again. And instead of just this one edge selected, now I pick the other edges as well, right? So let's go ahead and pick all of these edges. One, let's see if it allows me to hold down Control and pick these other ones too. Ideally it should. If it doesn't, let me just very fast redo this. So it should allow me to pick all the edges. There we go. Look, 1, 2, 3, and 4. So I selected all 4, and now I'm gonna create the walls. Okay, something like this. Look. Now again, if you look at the corners, you see that in the corner there is this cut, right? You can see there is this cut. Okay, that is called the corner relief, and if you don't have that, there is no way that you can form this sheet metal. Okay, so let's see a few other things. So one of the things you can do is this command here called unfold. So you can undo the folds, including the flanges. So here I say unfold, and I pick this, and then I unfold all of the bends, or if you want, you can just unfold some of the bends. Okay, you don't need to unfold all of the bends, but if you want to unfold all of them, you pick this and you okay that, and now it's flat. And now let's say, for instance, if you want to make a slot that one part of it is on this bottom part, one part of it is on this wall, and a portion of it is over the bend, you can do that here. Because if you want to do that cut in 3D where these walls are vertical, you cannot do that. But if you want here, let's say you go to sketch, and here you bring the slot command, right? And let me create a slot here. So seems like the command was turned off. There we go. Yep. So here, look. You see that? Get out. Now, before you click on this refold faces, you go to solid and cut extrude this. Okay, and you can see in 3D if you want. So go ahead and cut extrude this one like that. Yep. Now when you're done, you go back to sheet metal and refold. And you see, now you get this feature that you could not do in 3D. But when you unfold it and create this slot and fold it back, now you can have that format on it. Okay, so here I'm showing you all of these different things. And of course, you can create a hole on the object and you can pattern it too. So let's say if, for instance, you want to create a hole here, you can do that, right? Let's say the hole is just, and I make it 5 so it goes through, although 2 should be more than enough in this case. And the diameter of it is like 3 mils. And to place it exactly, I click on the references and provide the distances here, right? So you see, I place it exactly there, and then of course I can go to pattern and I can pattern it, right? So it says, what is the feature? So here you have bodies, faces, features. You pick the feature, and the feature in this case is the cut extrude here. And the axis that you want to repeat is this. And this, I make it the spacing, and the spacing is like 8 mils. And I want 5 of them, right? And then for the other direction, I want 4 of them with a space of let's say 6 mils. And if it's the wrong direction, you can always bring it back and do it the other way, something like that. Okay, you see that? And you okay it, and there we go. You got all of these holes that are patterned. Okay, so far I have shown you new component, I have shown you flange, I have shown you convert to sheet metal, as well as, of course, we did the extrude or cut extrude, hole and thread. We seen the unfold, we seen the create flat pattern, we seen the sheet metal rules. Let me very fast show you fillet and chamfer, which is the same as part. The other ones I want to show you are rip and bend. Okay, and once you see those, you have probably seen everything. So fillet and chamfer are exactly the same thing that you had in part. So here 1 mil, make that edge filleted, and you see it does. Or you can come here and you can pick this and say, hey, I want you to apply a chamfer to that, and you can do that as well. Again, let's say 1 mil with 45 degree or 1 and 1, and here we go. You see that one is chamfered. Okay, so no big deal. Now let me show you the rip. And one option that this flange has is, other than regular wall flange, you have this lofted flange. So I want to show you that lofted flange aligned with the rip. And another thing that you can do is a bend. Okay, you can do bend as well. So let me show you those very fast. So here we go on this wall and we create a standard simple, not standard, I mean a simple loft that we did in previous videos, right? So this one, then offset plane, and then let's say 100. See how far it's gone back. That is too far. Let's just bring it back. Was too much, maybe just 60. There we go. Now we create a square here, center rectangle, and make it a square. Something like that is good. And now we do a loft. So we do a flange, but a lofted flange. And I pick this and I pick that, and it gives me a flange. And I can have facet control, right? I can do chord tolerance. There are a bunch of things that you can do, but the basic thing is, here is your sheet metal, of course. And remember, in sheet metal, you can never get it to be a perfect circle, okay? So it is kind of the closest thing that you can get, a polygon. And now if can I do a flat on this, right? Can I flatten this, right? If I go here and say create a flat and say, hey, I want this to be my face, would it do it? And you see that it doesn't. Okay, so because this one has no cut, it's just a closed surface, so it cannot really be flattened, right? If I do a rip in it and take a small portion of it off, create a line in it, so say I want to do a rip on this, align, let's say this line with a gap of only 1 mil, and create this gap, you see now the sheet metal is opened. And now can I unfold this, or can I open this? So let's say if I want to unfold this and I want to pick that, you see here, now I can have the stretch of it. Okay, so it is doable. And so let me do a bend as well for you. So here we go ahead and we create a sketch again on this vertical wall, sorry, the horizontal plane. And let's say here I create this rectangle, right? And let's say I bring it on this side. And I create a flange out of it. Okay, so now if I want, I can bend it, but anywhere I want along any specific direction. So to do that, I need to sketch off the direction of that line. So I pick the surface. Let's say I want to bend it, but I want to bend it along this diagonal line. Can I do that? Yes. So what I do here is I go to bend, and I say I want to bend this guy, and this is the line that is going to be the line of bending. Now, depending on which side of this line that you click, that side will be held fixed, the other side will be bent over, right? Look here. So if I click on this side, you see, look, that side was held fixed, this side was bent. Now on the other hand, look, I just canceled it. Let me show you. So you see this one, this part was bent, that part was held fixed. Can I do the opposite? So can I go here and pick this side? Look, you see, that side that goes darker blue, that is the side that is going to be bent, and you can bend it to any degree that you want, like 150 or anything. And you can also again override the rules if you don't like the rules. So here we go. You see? So these are some standard and basic sheet metal things that you have. These are the commands that you have for sheet metal. There are not a ton of them in SolidWorks sheet metal. You have a lot more commands, but still should be enough for somebody to get a lot of basic tasks done for daily applications. Hopefully it was useful to you, and I will see you in the next video. Thank you.